how are you going to push through to the end? Okay, you have to complete your project, you have to complete your research, and you have to get your work published, right? Your work is not done until until the work is published, or the patent is given out, or the product is delivered to the customer, whatever, right? Okay, so this is where talking is good, right? Talking with others is good. Now, there's always the stereotype of the geek researcher who sits in a cubicle all day, never talks to anybody, is in computer science, and he's always banging away, writing code, solving problems, right? Never talks to anybody, and if you invite that person to lunch, they'll say, huh? What? Go away, right? So anyway, so don't be like that, right? So get ideas, bounce ideas off your advisor, bounce ideas off your friends. I don't know if you've had this experience, but many times, you know, in collaboration, oftentimes when you face a problem, you don't have to ask other people to solve it. If you just explain the problem to other people, oftentimes you'll see the solution yourself as you're explaining it. Does anyone have that experience before? A few of you, right? It really works, right? Tell your problem to others, and oftentimes by the time you finish telling them to the point they can understand what the problem is, then you've already solved the problem. So try to make this a social event. I mean, ultimately, the measurement of your success in research is at an individual level, right? It's you that do your part of the work, you that write your part of the paper. You know, you're developing this solution. So finally, it's up to you, but you can get lots of help in tackling that problem. Okay. Now, what else? Besides your immediate social circle, there's also you know, the other researchers in your field. So you should find out, in every branch of science and engineering and technology and so on, there are always going to be these few great researchers that you can look up to and emulate, right? In some cases it might be your advisor, then you're very lucky, right? But usually you don't end up at exactly the institute where the #1 researcher in that particular field is, right? So you should find those great researchers in your particular area of interest, and you should copy them, okay? I should say copy. You should not copy their work, right? You should not cut and paste or anything like that, right? But you should try to understand how they think. See if you can try to think like them in some ways, right? Now again, don't take this too far, right? Or you get stuck in a rut, or you become biased, right? But anyway, try to understand how they think. Try to understand how they present their empirical work. Try to understand what are the ways in which they develop their theoretical models, etc. Whatever is relevant in your area. How do you find these great researchers? Well, sometimes they'll just be known to you by their reputation. Your advisor might tell you about them, or you might just read their papers and you know these people are geniuses in your field, right? But again, this is where you can use some of the measures that we have for research productivity and so on that exist in academics, right? There's one called H-index, right, that tells you, do you know what H-index is? Who knows what H-index is? Nobody knows H-index. Ah, okay, this is a very important metric. Again, it's a kind of thing that can be gamed, but it is it generally, in a noisy way, it's a very valid way of determining how active or how strong a researcher is. So I need a whiteboard marker. Do we have any? No? None over here? Okay. I think every professor should always have whiteboard markers in their pocket, right? I don't know why I don't have one. Anyway, maybe we'll get one. Okay. Anyway, what is H-index? H-index is the number of papers that you've published with a certain number of citations. Okay. So, for example, if your H-index is 1, that means that you have at least one paper that has 1 citation. Get it? If your H-index is 2, it means you have at least 2 papers with 2 citations. If your H-index is 3, it means you have at least 3 papers with 3 citations each. Okay? So if you go to some of the great researchers in your field, you'll find some researchers have H-index of, say, 80 or 90 or 100. What does that mean? An H-index of 100. This means that this researcher has published 100 papers that have 100 or more citations each. Okay, how in the hell do they do that? Right, it's amazing, right? Well, okay. Number one rule is they work with a lot of smart people, right, and a lot of smart graduate students. Right? Anyway, yeah. So you'll find some researchers like that in your area. Now, even if they achieve that by working with a lot of people, right? Why is it that they're able to work with so many people? It's because they're so smart and so many people respect them, right? So again, these numbers are in some ways arbitrary, but generally a bigger number probably means a more productive and a more knowledgeable and a more networked researcher, right? So anyway, so in every field of study, if you search on the web, you'll find a list of the top 50 researchers according to H-index or whatever, right? Oh, thank you. Okay. I hope you didn't steal this from one of the graduate study rooms. I'm kidding. Okay. So. If H-index equals N, you have at least N papers with and more citations each. Okay, so you can check your H-index if you sign up for Google Citations. Or also, you can look in Scopus. Once you've got your first paper that's indexed by Google or Scopus, then you'll start to accumulate citations. Right? It takes a while, and usually it's actually a long process. Right? So many of you won't get there for a long time, right? Because first you have to do the research, right? And so that takes a year or 6 months or whatever, right? Then you have to write the paper. Right? And that takes another 3 months, 6 months, or a year. Then the paper has to be published. Right? Now, if it's a conference, it'll be immediate. Right? But if it's a journal, oh my God, it'll take forever. Right? Okay. So finally, your paper gets published in a journal. Then what happens? Then people start to read it, and then they might write papers that cite that paper. But then it takes time for those papers to get published and to get into the indexes. So from the time you start the research to the time you get your first citation might be 5 years, right? So it's a very long process, right? So you might die before you get your first citation, right? Sorry, I don't want to talk about anybody dying, right? But anyway, but it will happen eventually. So if you do work, you keep writing papers and putting your name out there, going to having your colleagues go to conferences, then you will get cited, and then it'll start to grow very gradually at first, and then you'll find it starts to, these things tend to start to occur exponentially as if you're still active. Okay, so yeah, so your H-index will grow as the years go on, and this is some measure by which you can actually tell that someone is active in research, publishing a lot of papers, and a lot of people are referring to that to the paper. Particular author. Okay, so your goal as a researcher, as a career researcher, is to get a high H-index, right, and so on. That just means doing good work and publishing your work in places that people will read it. Okay. Yeah, and by the same measure, when you're looking for collaborators, when you're looking for people to give you advice, you should be looking at the people that are in this position already, right? Now, hopefully they're not in that position for too long, because that might mean that they are stale already, right? If someone's last paper was written in the year 2000, right? Now, this might be fine in some areas, right? Some branches of science. In computer science, someone whose last paper was in the year 2000 is completely out of date. They're past the sell-by date, so you might not want to, engage with them so much. It's more the very active young researchers that are just getting started in their field. So these tend to be the up-and-coming stars, are kind of want to associate yourself with as much as possible. Okay. All right. So anyway, so find mentors, find people you can look up to, and then try to learn how they do what they do. That's a important aspect of getting through your research process. Okay. All right, another point I want to mention is empirical evaluation. Now, this is more or less important in different fields, right? So, for example, in mathematics, right, you don't need an empirical evaluation of a proof, right? The proof is either correct or not, right? And then that's the end, right? You've proven what needs to be proven. But in most of the fields of study at AIT, we tend to be more applied, right? And so we tend to do work that is more heuristic, right? And needs to be evaluated. We need some way to tell how good it is, right? It's not true or false or good or bad, right? Good comes in gradations in terms of some measure of performance, right? Be it speed, be it low cost, be it high accuracy, what have you, right? So we want, it's very important to take this seriously. So at the very beginning of your research, you should think about, how am I going to be evaluated when this research is over? What is going to be the methodology that I will use to evaluate my work, or that I should propose that people use to evaluate my work? Now, this is one of these areas where you must read, okay? Why should you read? Why can't you just come up with your own experimental methodology without any reading? Well, finally, if you just do your experiments your own way, okay, they might be right, they might be good, and you might get published, but other researchers are not going to accept it unless you follow the established procedures of your particular field, okay? So I give you an example. Sometimes I work in image retrieval. Okay, what does image retrieval mean? It means that, okay, I've got a picture, say, of my face. Okay, and I want to search all the internet for other pictures of the same face. Okay, that's an image retrieval task. I want to pull out the top 10 images over this data set of 1 billion images that are most similar to my face. Okay? So how am I going to evaluate it? I'm going to evaluate it on what percentage of that top 10 images that I retrieve are actually of my face, right? So that's a performance measure that we can use. Okay. So, but just doing something like that is not good enough in image retrieval. If you try to publish a paper where you do not use the commonly accepted standard databases, then you will not get published, okay? You must use the standard databases, and you must show that your performance is better than the state of the art, or at least under some circumstances, it's better than any existing state-of-the-art work, okay? So these experimental evaluations are extremely important. So whatever is your branch of science or engineering, you should take a look at some of the top papers in your field and see how do they evaluate their work, okay? And that should be a model for how you evaluate your work, okay? Again, you might think of a better way, and that's fine. But if you think of a better way, you probably want to do that better experiment, but also do the commonly accepted experiment as well, right? If you don't provide that baseline, that comparison with the existing state-of-the-art, people are not going to listen to you, okay? And the goal of your research is to be heard, right? But I don't know, one of the goals of your research is that it should be heard and read and accepted and adopted by others, right? So if you don't follow the empirical methodologies of your discipline, then people are not going to pay attention to you. It's very important. Okay, one of the last things, I'm talking longer than I thought I would. I didn't think I had so much to say. Anyway, yeah, so I want to give you some tips for working with your advisor, right? Your advisor is a resource, but sometimes a hard to acquire resource, right? So you should try to make the most of your time with your advisor if you're working with an advisor. So yeah, so try to be skillful, right? Don't go asking your advisor for how to solve trivial problems, right? Try to work hard, right? Show progress between each of your meetings with your advisor. Be smart in how you work, right? Don't waste your time on frivolous things, right? Don't waste the time that you spend with your advisor, right? Come with a plan. What are you going to tell your advisor? What do you want to get from your advisor, right? And so on, right? So don't ask for what you should do. You should come with your own ideas and ask for feedback on those ideas. Of course, if you're off base, then you should get your advisor's help in guiding you or putting you back on the right track. Okay. Yeah, when presenting your ideas and feedback, give sufficient background. So this is a very common thing. You go to see your advisor and you your research problem is right here at the very front in your frontal cortex, right? It's what you've been thinking about for the last week, right? Since you saw your advisor, or month, or however long it's been, right? And of course you understand everything, and you assume that your advisor is just as aware as you are. But of course, your advisor has been thinking about 100 different things since he or she last saw you, and so probably doesn't remember all these details. So yeah, most advisors are getting a little bit of gray hair already, or are already very gray, right? So you don't want to rely on memory too much, okay? So try to bring them up to speed before you before you jump into the new details. Okay. Take notes, think about the feedback, right? Make sure you understand the point. So sometimes if you're on the right track, your advisor won't say anything, right? They'll say, oh, it sounds good, go ahead, right? But in other cases, if your advisor sees that you're going down a wrong path or that you need help, they will offer some suggestions. So you really don't want to make your advisor repeat himself or herself more than once, right? So listen and understand, and try not to leave the room until you're sure you understand what your advisor is trying to tell you, okay? If your advisor's full of crap, it's a terrible idea, right? Tell him that or tell her that, right? Don't be shy. Make sure you understand and that the feedback or the idea is applicable to your situation. Okay, talk to others, right? There's no faculty member at AIT, as far as I know, minds if you come and try to talk to them about your particular research problem. They're happy to share some ideas with you, even if they're not your advisor. Okay, yeah, talk to others as much as possible. Okay. All right. So that's a tip for. This is not really about how to do research, but about how to collaborate with one particularly very important person on your research. Okay. Then the last thing I want to mention is the survey. So all of you, if you're just starting some research projects, one of the first things that you have to do is called the literature survey, right? And so in the literature survey, you have to synthesize all the work that is related to your particular topic, right? And try to make a critical analysis of what's been done up till now. What are the gaps, and what can I use, what is not useful, and so on, okay? That's the purpose of, okay, in an AIT thesis or capstone project report or dissertation, it's usually chapter 2, right? So everybody knows chapter 2, right? So yeah, so this is where you have to be a little bit selective in what you read, right? Because what you're going to find is that, okay, like I say, this is fake, but there are approximately 3 zillion academic research papers on the internet, and they're not all good, right? So I want you to be selective and try to identify, be as productive as possible by reading the work that is most likely to be good, okay? So how to do that? Okay, so yeah, 0.1% are genius, 4.9% are solid and possibly useful, and 95% you don't want to waste your time on, right? So that means that, okay, 1 out of 20 papers is likely to be good. So when you do a search on Google, right, you're going to get a lot of hits for anything you enter in Google, right? No matter what you ask Google, it will tell you more than you want to know, right? So you have to find that 1 paper out of 20 that is good, okay? Now, what's more important in terms of having your work accepted by others, if you cite a bunch of this possibly low quality research in your report, then you're going to look bad, okay? So other researchers will immediately, they'll get a bias against you. They say, oh, you don't know what you're doing. You're not smart. You read junk research, right? So don't get trapped into that situation, okay? So you want to know what's good and what's bad. And it's not easy to tell if you're in a particular area, right? But yeah, so first of all, you should understand these different types of academic publications, right? These are the main ones: the journal paper, the conference paper, the book chapter, and the technical report, okay? I write them in this order. Now, by the way, this is not necessarily the order for all areas, but in computer science and probably most of engineering, right, the journal papers tend to be more authoritative, right? The conference papers tend to be a little less authoritative, but more authoritative than book chapters or technical reports. The reason for this is that a technical report is not peer-reviewed, right? So anybody can write a technical report, put it up anywhere, right? A book chapter may or may not be peer-reviewed, right? In some cases, edited books are peer-reviewed very, very rigorously, especially in the social sciences, right? But in other cases, right, it's just, okay, a bunch of people got together, wrote their own chapters, and put them together in a book, right? Okay, but for conferences, and even more so for journals, then we have standards of peer review, right, that are trying to be rigorous about that. Now, again, this is a system that gets gamed. There's a lot of noise in the peer review process. A lot of crap gets through, and a lot of good work doesn't get published in you know, the place that it deserves. Okay, but by and large, this is true. Okay, so I want to mention IEEE. Okay, so sometimes you know, so IEEE covers many of our, not all, right, but many of our fields. Sometimes I'm talking to a student and they're telling me about a paper they read, and I say, where was that paper published? And they'll say, I think it was in IEEE, right? And I'm like, oh, really? Okay. So the first thing to know about IEEE is that it has some of the best publication venues in the whole research universe, and it has some of the worst as well, okay? So the fact is that anybody who wants to make a conference, including a junket conference in Krabi, right? Now, I don't want to criticize anybody who's gone to Krabi for a conference. It's a beautiful place, and they probably have good conferences there. I've been to conferences in Krabi, okay? But good conferences only, right? Yeah. So anyway, so you're going to have a junk conference in Krabi, right? As long as you're on a topic related to engineering, right? What is it? Industrial and electrical and electronics engineering? I forget what it stands for. Oh, by the way, okay, this is completely off track, but I once had a Pakistani student. He was a doctoral student. He got a paper in a top IEEE conference in the U.S. And he went to the U.S. Embassy for his interview for the visa. And I'm not sure if this is why he got rejected for the visa, but the person at the embassy asked him, "What does IEEE stand for?" He's like, I'm not sure, right? Okay. Anyway, if you're going to go to an IEEE conference, yeah, he for some reason he eventually got rejected for the visa. And I still don't know why. I wrote lots of angry letters. This is my country and my embassy, right? I really tried to find out, but they wouldn't tell me, the jerks. Anyway, so you should know what IEEE stands for, okay? Okay, anyway. Yeah, so anybody can get IEEE endorsement of their conference, right? So it could be a bad conference, or it might be a good conference. In my own area, the top conferences are generally IEEE, but many poor ones are as well. So anyway, if you're reading a paper and all you know is that it's in IEEE, that actually is nothing. You need to know if it's in a journal or a conference. Is it a good journal, or is it a bad journal, or is it a good conference, or is it a bad conference? Okay, so how can we know what are the good journals and what are the good conferences, right? Well, these are the ways that you can understand this. So citations, okay? If the paper is in a bad journal but it has a lot of citations, then it's probably still a good paper, right? So you might consider reading it and citing it in your own work. What else? If the paper is maybe a very new paper, right, it hasn't had time to get citations, but it's in a top journal, then it might well be a good paper. Not necessarily, but it might be a very good paper, okay? How can you tell if a journal is good? Well, you look, you know, it's hard to say, but generally, journals with higher impact factor tend to be stronger than those that are not, just because they're more competitive, more selective. So people with stronger results tend to submit to those journals. Again, it's not really true, right? High impact factor doesn't necessarily mean high quality, but as a broad trend, it's approximately correct. Okay. Okay. So conferences. Every field of study, I believe, has rankings of the conferences. If conferences are important. In some areas, conferences are not important. But for example, in computer science, you can look at rankings of conferences and how high quality they are. You know, is it in the top 10%, or is it in the middle, etc. Okay. experts, talk to your friends, talk to your advisor, etc. And please learn to use Google Scholar. This will tell you a lot, right? It'll tell you how many people cited a paper. It'll actually give you links to the papers that cite a paper. So you can do a lot of very useful bibliometrics with Google Scholar. So this is an important tool for you. Okay. All right. So that's it for today. So I hope that by now, if you had no idea what research was, you know a little bit more. Okay. Now, I hope that you have an idea now of how to get started if you didn't before. And yeah, you know some of the tools you should use. And I want to remind you again: think, think, think. Think before you read, and then read some, and then think some more, and then think some more, and then think some more. Okay. So think a lot, and that should be your that should be your main activity as you move forward. Okay. So good. So I'm sorry I talked a little bit longer than I thought I would or should. But anyway, I hope that some of this information was useful to you. And so I think we have plenty of time for some questions and discussion, if you like. Any questions or points of discussion?
So for the H-index, what is the contribution of taking a third author? Their contribution is also indexed for the H or is the first author?
Yeah. So the question is for H-index, what's the importance of first author, second author, and third author, and so on? So as far as I know, for H-index and actually for any citation index, the order of authorship does not matter. So all authors on a particular paper get credit for every citation to that paper. So this is one metric that, it doesn't matter if you have 10 authors on a paper or 100 authors on a paper. Even if you're the very last author, right, you get full credit. This is this is kind of weird, right? In engineering papers, usually at least, the first author tends to be the one that has contributed the most, and then the second and third, but everybody's getting equal credit. So in some sense, maybe it's not fair, right? Anyway, that's the way it works. In some cases, I know that when some people try to evaluate research, they'll actually divide whatever it is by the number of authors on the paper, right? So you might get only, if you have one citation to a paper with one author, you get 1 point, and if you have one citation to a paper with 2 authors, you only get half a point, right? That might be the case in some particular institutes, right? But H-index, according to Google or Scopus, does not take that into account. About software, software for your research. Okay. Yeah, Google Scholar, right, is one. I hesitate to say this because I know that most of you are not computer people, but I think, dare I say it? Okay, my students will laugh at me. Do you know this tool called LaTeX? This is a great tool for report writing and typesetting. So you might not appreciate how important it is that the papers that you write should look good, should use proper formatting, and have a good appearance. The mathematics should be typeset properly. Okay, I think writing in LaTeX, just switching from Microsoft Word to LaTeX will improve your writing. Okay, now if you're a Microsoft person, you might not believe that, but I think it's true. Yeah, and so related to LaTeX is a very useful tool called BibTeX, which is a bibliography database. Now I know people that in the Microsoft world use something called EndNote, and maybe there are more recent innovations besides EndNote. But anyway, BibTeX is a very nice tool. It's just a text file format that lets you store all of your papers. And then when you refer to a paper in your paper, you just put a note to refer to a particular entry in this database, and then the citation is automatically formatted. So by using tools that are meant for professional level typesetting of academic research, this tends to put you in a mindset of actually producing professional level academic reports of your research. So this will help you to emulate, like I was talking about, to emulate others. Okay, so Google Scholar, LaTeX, BibTeX. I mean, every field has its own specific software that might be useful. For example, if you're doing statistical analysis, you might be using R or SPSS or SAS or something like that, right? MATLAB, of course, is a great research tool throughout engineering. I cannot stress enough how good it is to learn. Well, actually, okay, if you don't know me, I'm actually an open source advocate, so I'll say you should learn Octave, which is a MATLAB compatible. It's a MATLAB compatible. What do you call this? I don't know. Toolkit. I'll just say a tool. Okay, Octave is a great tool. But yeah, I think beyond that, I think the tools that are applicable are going to from field to field. Yeah.
So impact factor is one of the parameters to judge the journals. And there are certain parameters like
to judge a conferences, how are you supposed to know if a conference is good or not?
Yeah, that's a good question. I think there is no standard well-defined criterion for conferences, but if you look at particular research fields, then you'll find rankings that are made by, I don't know what they are, but maybe by citation counts or something similar to impact factor. So there have been attempts to rank conferences according to something like impact factor. So if you can find a resource like that, then you can find it. But there's no organization like Thomson Reuters that's looking at all conferences in the world. By the way, one important distinction is whether or not your conference proceedings appears in Scopus. Okay, so this is it doesn't necessarily mean that the conference is better, but it does mean that if it's in Scopus, at least it's included in all of these counts, and so then your paper is more likely to be seen and referred to if it's in a Scopus indexed conference as opposed to something that's left out of Scopus. So but yeah, again, you basically find this out by seeing where the top researchers in your field are publishing. That's probably the best way to find the best conferences. Whoever's your hero, go find out where he or she publishes, what conferences he or she goes to, and then try to go to the same conferences. Yeah. Yep.
Hello, sir. Hello, sir. I've seen some authors publishing each of their objective of their main journal in the conferences. Like if they have 3 objectives, they will publish in 3 conferences, and in total they will publish their journal at large. Is this a method to get escape from this kind of thing, like
scooping? Oh, yeah, that's a good point. Yeah, so do you hear the question, right? Some people will publish 3 conference papers and then put those 3 conference papers together into one journal paper and finally submit it. That's exactly right. Actually, any way that you can get your paper officially published early is good to avoid this scooping problem, right? So maybe you have an idea in 2014, you start to work on it, and then in 2015, somebody publishes something very similar. If there's some public record that you were working on this and you actually developed this idea yourself in 2014, then you can escape this problem, and you still have a good chance to publish your work in a journal later, because you can establish that I thought of this first. That's a very good point. I should mention that different journals and different fields have different criteria for this conference versus journal distinction. Sometimes when you write a conference paper, get it published, and then you extend that work for a journal. I've had this experience many times where the reviewers say, hey, this is the same paper as you published in such and such a conference that's available on Scopus 1 or 2 years earlier. Right? So they'll criticize you for publishing essentially the same work in the conference and then submitting it to a journal. But at least in computer science, this is a very common thing to do. You first publish a brief report in a conference, preliminary work, and then you expand and extend the empirical evaluation and submit to a journal, right? So this is very well accepted. But yeah, some reviewers don't get it, right? And so they'll still criticize you for this. Anyway, but you have to check very carefully what are the standards in your field. This is not the case for every field, that first you go to a conference and then you go to a journal without much modification. So this is where you should talk to your advisor, ask their opinion, and also every journal should publish its publication and its plagiarism policy. So you can understand You know, if you publish the same work in 2 places, that could be considered self-plagiarism, right? If you don't follow the rules properly. Okay, so be very careful about this. IEEE, by the way, has very good set of documents online for understanding self-plagiarism. So I'd encourage you to look at the IEEE plagiarism rules. So it will help you to avoid self-plagiarism. You don't want to shoot yourself in the foot by doing some inadvertently of self-plagiarizing yourself. Any questions? Yeah.
Earlier you mentioned about thinking and then reading.
Yes.
How likely it is to result in getting scooped?
How likely it is to
Getting scooped.
getting scooped?
Yes.
You mean thinking before reading?
Yes.
Yeah. I guess that's why I would say don't only think, right? Because then, yeah, not only do you run the risk of going down some path that finally nobody will accept your work, but also, yeah, you might be exactly replicating some thought that others have had. This happens to me all the time. I think about a problem for a while and I say, I got the best solution for this. And then I tell somebody about it and they say, that was already published last year, right? It happens all the time. But yeah, so yeah, that's why you should not go too far down this thinking path without also reading. Yeah, you're right. More questions? Okay, so yeah, again, I'll say again, don't listen to me, but listen to what some of the great researchers in your field have to say, right? Yeah, definitely think hard and yeah, don't read too much. Okay, well, thank you.
Thank you very much, sir. On behalf of Student Union and all the students, I would like to invite Abhishek, SU President, to present a souvenir to Dr. Matt as a token of appreciation. Okay, thank you all of you. Thank you very much, sir.